Hello again, and we're back and we're solving equations, but a different type of equation. We're going to add to your toolkit in solving. All right, now number one is a review problem. Hopefully you can solve that one. Use your notes from yesterday, look at my video from the other day, and I'll help with those. But let's look at some problems from number two and some problems from number three today. So if you look at number two, it says solve for x by first rewriting the equations in a simple form. So solve the following equations by first rewriting. And then we're going to do A and B together. So if A, it says 0.4 times x minus 2, or some number minus 2, is equal to 3.4 minus 0.2x. Now, don't get me wrong. You can solve this as is, but then you'd have to work with decimals, in which you might have to use a calculator, and there's easier ways. Remember, we can't change the problem. So that's the big thing is, remember, you can't change the problem. You have to solve the problem in front of you, okay? So one thing we can do without changing this problem is notice how they're all 0.4, 3.4, 0.2. Well, if I say these how they're said, that's 4/10. If you remember back from elementary school, that's 4/10 too, and that would be 2/10. Well, what we can do is we can multiply everything by 10. And by everything, I mean each number times 10. Because if you multiply by 10, that will make the decimal move over 1 to its right. So when you do 10 times 0.4, that just becomes 4. And then since this is all together, like this is all one term because it's together, we don't actually multiply the other terms by 10 because we already did that once. So that just makes 4x minus 2. And notice, you don't trust me, I'll show you on a calculator. If you did 10 times 0.4, notice how you get 4. All right. So your little trick, I'll maybe write this up here, trick is when you times by 0.4 or times by 10, it moves the decimal to the right one. If you want to take this farther, if you times by 100, it moves the decimal to the right 2 times, and so forth. A little understanding how numbers work. So if we come back to A, I did 10 times all of this. 10 times 3.4 is going to make that 34. Well, that's going to move 1 to the right. And then if we do 10 times negative 0.2, well, that'll just move that 1 to the right, so you get negative 2x. And notice it's the same problem, just a bigger version of it. This is a problem that's 10 times the size, but it's still the same problem, right? So we keep going through this, and now we can solve it as is. Well, I'm going to distribute the 4x. So you get 4x minus 8 equals 34 minus 2x. This one gets trickier because we have x on both sides, so let's get the x to one side. Doesn't matter which side, but I'm going to try and get them on the left side. So I'm going to add 2x to both sides to make the x's on the right side go to 0. So then I get 6x minus 8 equals 34. And then add 8 to both sides. Let's bring my work up here. So then I have 6x, that goes to 0, equals 42. And then lastly, this is 6 times x, so the opposite of times is divide. And what you get as your final answer here is x is equal to 7. And that's how you solved A. And notice we were able to work with whole numbers and not decimals. Not saying you can't work with decimals, but it's nice to be able to work with numbers we're more comfortable with. Now, what about B? Now, B, same thing, is these numbers aren't decimals, but they're very large. So notice when we times by 10, we move the decimal to the right one. Well, the trick too is if you divide by 10, it moves the decimal to the left one. Divide by 100, that would move it left 2, and so forth. But notice, and every number has a decimal at the end there. It's like 500 point, does it have any extra parts to it? These don't. It was 5 or 2,000 even. I said 500, 5,000 is what I meant. So if I want to move this back 1, 2, 3 to just work with the number 2, then I'm going to divide all of these numbers by 1,000. And if you do it to 1, you have to do it to the whole thing. You can't change the problem, right? You can't change the problem. So I'm going to divide that by 1,000, divide that by 1,000, and divide that by 1,000, as that will move the decimal to the left 3 times. So moving that to the left 3 times, that just becomes 2, and all that x minus 24 stays because that was all together. Plus, and then when I do 5,000 divided by 1,000, move it to the left 3 times, I just get 5, equals 18,000 divided by 1,000, move that to the left 3 times, or use a calculator if you don't trust me. You get 18. Same problem, just a much smaller version of it. Okay. Then solving through it, distribute to 2x. You get 2x minus 48 plus 5 equals 18. We can combine these two numbers. So we get 2x minus 43 equals 18. Add 43 to both sides. You get 2x equals 61. And divide by 2. And you get 61 over 2, or if you put that in a calculator, it's 30.5. Either answer is correct, but there you go. So you can see that's a new technique we have of solving equations, where with decimals, we can multiply by 10 to move the decimal over to the right. If we divide by 10, we can make that number smaller by moving the decimal to its left. Right? Now let's look at number 3. So we've looked at decimals, really large numbers. What about fractions? So how do we solve if we say we look at, we'll do A and B together again. Right? And the lighting coming in through my room is very bright right now. I'll zoom in so you can see this better. So the lighting doesn't affect us as much. Okay? So for part A, 5x over 2 plus 15 over 2 equals 5 over 2. And that can be tricky to solve. We don't like solving this. So what we can do is we can multiply each of these terms by 2. So let's double this whole equation. And when we multiply by 2, remember that timesing by 2 is the same as like 2 over 1. So if I did 2 over 1 times 5x over 2, well, that 2 divided by 2 are going to actually cancel to 1. Like 2 divided by 2 is 1. And notice we're just left with 5x, or 5x over 1, which is 5x. If I do 2 times 15 over 2, that 2 and that 2 are going to go to 1, so I'm just going to be left with 15. And when I do 5 over 2 times 2, remember that's 2 over 1, that 2 divided by 2 will just be left with 5, or 5 over 1, which is 5. Same problem, just double now. And then we can solve for this as we know how to do, which would be minus 15 first to both sides. Then we'll have 5x minus 10, divide by 5. And your final answer here is x equals negative 2. Okay. And then we come to B. See if I can move that one in the shadow. Remember, pause the video, go back if you need to see it. Now this one's tricky because it's a different fraction. So we actually have to do 2 things here. We're first going to get rid of the dividing by 3. So we're going to multiply the whole equation by 3. So if I multiply by 3, so that's 3 over 1 times x over 3. The 3 on top and the 3 on bottom will go to 1. So we're just left with x. Plus, now here, notice if I write this off to the side, we're saying 3 over 1 times x over 5. Nothing cancels there. And multiplying fractions, you just go straight across. So what we're going to get here is actually 3x over 5 still. So that didn't go away as a fraction. Equals, and 2 times 3 is 6. Okay. But now, so we got rid of one fraction. We need to get rid of the next. So then we're going to multiply everything by 5 to get rid of the fraction here. 5 times x is 5x. If you do 5 times 3x over 5, so if you did 5 over 1 times 3x over 5, well, that 5 on top and the 5 on bottom will go to 1, in which you're just left with 3x over 1, or 3x, equals 6 times 5, which is 30. And then we can combine these two. I'm going to write it up here, where 5x plus 3x is 8x, equals 30. Divide by 8. And it looks like we're going to get a fraction here as well, which you can leave your answer as that, or you can simplify this by dividing by 2 and get 15 over 4, or you can put this in a calculator and get 3.75. They're all correct answers there. We don't really care which one you choose. Okay. Oh, you didn't see any of that. The lighting, man, how bright is that? So there it is. There's the last problem. I'll leave it there for you so you can look at it. So quite a bit. Definitely work through it. Go slow. Understand what I did from step to step is that's the best way for you to make sense of it. Okay. Try it yourself because that's where the real learning will happen. All right. Good luck. Bye-bye. Reach out to your teachers or myself if you need any more help.